Good evening, everyone. Good evening. Good evening, everyone. Yeah, can we start? Yeah, fine. Then can you go ahead? Yeah. What is the answer for this? Can you go ahead? Everyone try this. Everyone try this. Everyone try. What is the answer of this? Everyone try. Everyone can try this. Yeah, just wait. Some small problem. Just give me 1 minute. Give me 1 more minute. Yeah, some export problem. Yeah, now it's fine. Yeah, sorry for this. Now some export problem. Now it's fine. Yeah, sorry for this. Yeah, can you go ahead? What is the answer of this problem? What is the answer of this problem? Yeah, Ashutosh, Srishti, what is the answer of this problem? So if you observe clearly, for all there exist, there exist for all. You know, from this side it is not possible. From this side it is not possible, right? From this side it is not possible. Yeah, fine. So if you see this one properly, from this side not possible, from this side not possible, right? But from this side it is possible. We discussed in the classroom many times. So A not possible. He's saying which one of the following is well-formed formula is a tautology. Well-formed formula is a tautology. Tautology means it should work both the side. Tautology means it should work both the side. Right? Tautology means it should work both the side. Yeah, you can check now. Option A fail. Only one side will work. You know this very well. And one more, second one, if you observe clearly, see, for all there exists to, here also for all there exists, there is no problem. R goes to S, R goes to S, goes to S. So this is going to be, this is not a valid one. This is not a valid one because if you take these both as false, if you take these both as false, right, employees operator, it became a true. It became a false. True false becomes false. So it is not possible. It's not possible. We discussed many problems in the classroom. We discussed many problems. Next one, if you see the option C, if you see the option C, left side, right side, same. This is A arrow B. Right side, if you see negation A R B, same thing. Negation A R A B. So C is the answer for this everyone now. So if you see the option D, everything same, P of X, Y, P of Y comma X. Here X comma Y, here Y comma X, right? These two not. So answer is C, everyone know. If anyone having any objection, please let me know. If anyone having small objection also, please let me know. Which one of the following well-formed formula is a tautology? So I think option C is a tautology. It will work both the side. See, it is a both the side. It will work both the side. Option A will not work both the side. Option B, right? One side also it don't work. Option B, one side also it don't work. Option D, it don't work. So answer is option C. I think everyone fine. Everyone is fine. Let's go to the next problem. Yeah, can you try what is the answer of this? The number of combinations of truth values for P, Q, and R for which the statement is true. The number of combinations of truth values of P, Q, and R for which this statement is true. This statement should be true. This statement should be true for how many combinations? This statement should be true for how many combinations? The number of combinations of truth values for P, Q, and R for which the statement is true. So it is a NAT type, NAT type question. It is a NAT type question. Can you give the answer for this? Can you give the answer for this? The number of combinations of truth values for P, Q, and R for which the statement is true. Can everyone give that? Can everyone try this? Given statement true for how many combinations? Given statement is true for how many combinations? Everyone can try. Given statement is true for how many combinations? I think everyone know it is a double employees. Everyone know it is a double employees. Double employee is true if both the side is true. Double employees is true if both the side is true. So left true, right true, then true. Left false, right false, then also true. Double implies is true if both the side true, both the side is false. Then only it is going to be true. So for how many combinations this is going to be happened? For how many combinations this is going to be happened? Let's check one by one. Let's check one by one. Negation P, double implies Q, and negation P implies R. Right? So if left side true, right should also be true. If left false, right also false. Let's try. Let us assume this is true. This is true means P become false. Negation P true means P become false. Let's substitute right side. Let's substitute right side. P become false. P become false. Right? So can you help me now? P become false. P become false. False implies anything. It should be true. Negation true. It should become false. Q and false. Q and false. It will become false. So I think, yeah. So whenever left is true, P become false, P false, P implies R will become true, right? Negation true becomes a false, Q and false becomes a false. So left true means right became false. So I think this is not the one which will give true. Let's assume left is true. Let's assume true done. Let's assume left is false. Let's try this also. Let's try this also. Let us assume left false. Left false means P become true. P become true. Left false means, right? Left false means P become true. If P become true, it's a true. If P become true, it is a true. Now remember, is asking the number of combinations of truth values for P, Q, and R for which the statement is true. Remember, left is already false. If you want to make the statement as true, right should also be false. Right should also be false. Now say, how many ways you can make it false? Right should be false. Left is false. Left false means right should also be false. P already true. P already true. So remember, if Q is right, Q true. Sorry, Q is false. Q is false. Right. So it will be Q is false. Q is false. Then it is going to be a right false statement. Q false. Then it is going to be a false statement. Right. And one more. P is already true. P already true. What about R value? What about R value? So R will be true also okay. R will be false also okay. R will be true also okay. R will be false because Q is already false. So R may be true. R may be false also. What else? What other options you have? What other options you have? Let us assume that Q is true. Q is true. Assume. Right? P already true. R will become false take. So then it will become true false. It will become false. False and true. It will also become false. I think in my opinion, three combinations. Three combinations. So the number of ways to assign the truth values to PQR such that given statement is true becomes three ways. Three ways possible. Three ways possible. Three ways possible. Case number one. Case number one. Assume left true. Prove right also true. It is not possible. Case number two. Case number two. Assume left false. Prove right also false. Yeah, to prove right also false, we have three ways. One way is going to be see anyhow P true. So remaining things you have to adjust. Q and R. Q false means R may be true, R may be false. Q true means R should be false. So there are three ways. To make the given statement true, we have three ways. We have three ways. I hope everyone got it. I hope everyone got it. Yeah. Can you go to next problem? Can you try this? Raghava, can you try this? If F1, F2 and F3 are propositional formula expressions over some set of propositional variables such that F1 or F2 implies F3 is a contradiction, then which one of the following are necessarily true? Then which one of the following is are necessarily true? Yeah, can everyone go ahead? Remember F1, F2, F3 are propositional formulas or expressions. They are not variables. They are not propositional variables. They are propositional formulas. They are propositional formulas. You want to prove, see this one, such that F1 or F2 implies F3 is a contradiction. Then which one of the following is necessarily true? Can anyone try this? Can anyone try this? Can anyone try this? Can anyone try this? You want to prove F1 or F2 implies F3 is a contradiction. Contradiction means false, all false. You want to prove, right? F1 or F2 implies F3 is equal to contradiction. Means all false you want to prove. How? Remember everyone, remember this. Everyone remember this. F1, F2, F3 are propositional formulas. They are not variables. They are not variables. So if you want to make this as false, if you want to make this as a contradiction, the only possibility is a true-false combination required. True-false combination required. Left side true, right side false combination required. Left side true, right side false combination required. Left side true, right side false combination required. So let's see one by one. Let's see one by one. So can you help, F3 is a contradiction. F3 is a contradiction. Yeah, F3 should be contradiction. True. F3 should be contradiction. That is perfect. It should be false. So I think I will agree C true. I will agree C true. What about B? At least one of F1, F2 tautology. Suppose assume that F1 is a tautology. F2 is a false. Overall become true. It is false or it is true. It will become true. Both false not possible. Both false not possible. Both false not possible. Remember everyone, the F1, F2 is not a variable. They are formulas. When you say formula, it itself having so many possibilities. F1 formula, let's see this one. F1 formula is not tautology. Let us assume that this is F1. Let us assume that it is F1. F1 is a formula. There are so many possibilities. Let us assume that it is F2. Right? Let us assume that it is a F1. These are the variables, some variables. Some variables are here. To this variable, it is a F1, it is a F2. To this variable, it is a F1, it is a F2. In between, you are using R operator. Let us assume to these variables, let us assume it is true. It is false. Overall become true. To this variable, this is false. This is true. It will also. But see the interesting story. To these variables, see, if you observe clearly, total F1 is not true. Total F2 is not true. Understand this. You cannot say F1 is a tautology. You cannot say F2 is a tautology. You cannot say at least F1, F2 is a tautology. You cannot say. See, F1 is the combination of true, false. F2 also combination of true, false. So this is also wrong. This is also wrong. F1, F2 are tautology. Then which one of the following necessarily true? I cannot say A is true. I cannot say B is true. F1, at least one of them is at least one of the F1, F2 is a tautology. I cannot say. F1, if you see combination of true, false, how can I say F1 is a tautology? F2 also combination of true, false. How can I say F2 is a tautology? At least one of them is a tautology. I cannot give guarantee. If anyone say F1 is a tautology, I cannot say, because F1 is a formula. Means variables are there. Based on those variables, some formula there. See, to these variables when I construct f1, right? Sometimes, right, some variables, some values, it is true. Sometimes it is false. So f1 is the combination of true false. F2 also may be combination of true false. So I cannot say at least one of them is a tautology. F3 is a contradiction? Yes, because you want true false combination. Right side should be a contradiction. True. F1 or F2 is a tautology? F1 or F2 is a tautology? Can anyone help? F1 or F2 is a tautology? Can anyone help? Did you try it or wrong? F1 or F2 is a tautology? Did you try it or wrong? What about option D? What about option D? F1 or F2 is a tautology? F1 tautology is wrong. F2 tautology also wrong. But F1 or F2 is a tautology. If it is not tautology, left side become false. False implies anything, it will become. Right? False implies anything, it will become a true. But I want finally contradiction. So I think D also right. Answer is C, D. Answer is C and D. Answer is C and D. So it is a really tricky question. So that is the reason I want to give this. It is a really tricky question. I want to give this. Remember, F1 is not a variable. F1 is a formula or a expression. When you say it is a formula or expression for the given truth values, this expression may be true, may be false. Maybe half true, half false. Maybe half true, half false. Fine, perfect. Let's move to next problem. Yeah, can you try this? Can you try this? Everyone try this. It is a MSQ. It is a MSQ. It is a MSQ. Can everyone try this? Everyone try this. Everyone try this. Yeah, I think everyone know. No machines are intelligent. No machines are intelligent. You want to say that no machines are intelligent means all machines are dumb. No machines are intelligent. Right? No machines are intelligent. That means if you observe clearly, for all XO, see this one. For all XO, if it is a machine, it cannot be intelligent. For all XO, if X is a machine, it cannot be intelligent. And one more way of saying, for all XO, if it is intelligent, it cannot be a machine. If it is intelligent, it cannot be a machine. So I want to say BC correct. I want to say BC correct. For all XO, if it is a machine, it cannot be intelligent. And one more thing is, if it is intelligent, it cannot be a machine. Am I right or wrong? Please check once. No machines are intelligent. If it is a machine, it cannot be intelligent. If it is intelligent, it cannot be a machine. Check one time. Check one time. No machines are intelligent. If it is a machine, it cannot be intelligent. If it is intelligent, it cannot be a machine. If it is a MCQ, happily you can select option C. If it is a machine, it cannot be intelligent. If it is a MCQ, if it is a MSQ go for BC. MSQ go for BC. MCQ go for C. Right? If it's a MSQ, go for BC. If it is a MCQ go for C. MCQ go for C. The actual answer is C only. Because he said one line, no machines are intelligent. If it is a machine, it cannot be intelligent. If it is intelligent, it cannot be a machine. Fine. So if it is MCQ, you can go for means whatever order he mentioned. Whatever order he mentioned, you can go for that. If it is a machine, it is not intelligent. Right? So I think meaning wise, if you see B also looks similar, so you can go for B also. Yeah, let's go to next problem. Can you try this? It is a very interesting problem. Can everyone try? It's a very interesting problem. Can everyone try? It's a really interesting problem. There are 6,561 functions from X to Y. There are 6,561 functions F from X to Y. The size of Y is 3. If X is the power set of A, then how many binary relations on A are possible, which are neither reflexive nor irreflexive? There are 6,561 functions. Right, next one. Functions are from X to Y, where size of Y is equal to 3. If X is a power set of A, then how many binary relations on A are possible, which are neither reflexive nor irreflexive? It's a really nice problem. Please, can you go ahead? It's a really nice problem. Can you please go ahead? Everyone try this. Everyone try this. It's a very interesting problem. Let's see how many people will give. It is also NAT problem. It is also NAT problem. It is also NAT problem. Can you go ahead? Everyone try. Let's see how many people will give. Yeah, good evening everyone. There are 6,561 functions from x to y. Size of y is 3. If x is the power set of A, then how many binary relations on A are possible, which are neither reflexive nor irreflexive? Yeah, I'm giving the answer. I'm giving the answer. Can everyone see this? I'm giving the answer. Can everyone see this? Can everyone see this? Can everyone see this? Suppose x contain, assume, x contain 10 people, assume. Y contain 5 people, or y contain 3 people. If x contain 10 people, y contain 3 people, x to y number of functions how many? For every element of x, 3 choices. So 3, 3, 3, 3, like the 10 choices. Total functions are 3 power 10. If at all x size is 10, y size 3, then the total number of functions possible is 3 power 10. 3 power 10 functions possible. But we don't know what is the x size. We don't know what is the x size. X size is assume x only. So 3 power x 3 power x is equal to 6,561. Total functions is equal to, right? So 3 power x, which is 6,561. Now, but I want x value. Apply log x. Log 3 base 3 is equal to log of 6,561 base 3. So finally x is equal to log of 6,561 base 3 by log 3 base 3 is 1. Log 3 base 3 is 1. You calculate properly, x value becomes 8. X value become 8. Log, right? Apply the log, use the calculator, apply log. X value become 8. So size of x is 8. But remember, what is the x here? If x is the power set of A, x is the power set of A, which is nothing but x is nothing but 2 power A. 2 power A. So 2 power something is nothing but 8. So 2 cube is 8. So I think A size is 3. So A size of A is equal to 3. Size of A is equal to 3. Size of x is 8. If x is the power set of A, means x is 2 power A. 2 power A is 8, means 2 cube is 8. So A size is 3. A size is 3. Now if A size is 3, A cross A contain, if A size is 3, A cross A contain 9 elements. A cross A contain 9 elements, right? If A cross A contain 9 elements, everyone know A cross A contain 9 elements. You take any subset of these 9 elements, it is nothing but a relation. So total number of relations, total number of relations, total number of relations, total number of relations are 2 power 9. Because over A cross A, you take any subset. Over A cross A, you take any subset, it will become a relation. Total number of relations are 2 power 9, because he is asking relations only. How many binary relations are possible? Over A, 2 power 9, 512. If A is equal to assume that 1, 2, 3, 1, 2, 3 into 1, 2, 3. A cross A, if you do totally 9 combinations. Totally 9 combinations. If anyone say, sir, what are those 9 combinations? This may be the case. 1, 1, 1, 2, 1, 3, and so on, and so on. Lastly, 3, 1, 3, 2, 3, 3. So these are the 9 people. So 2 power 9, 2 power 9 relations possible. 2 power 9 relations possible. But remember, right? Remember everyone, one of the relation, 2 power 9 relations possible, okay, right? So one of the relation is A cross A itself is one relation. One more relation is only this, only 1, 1. It's a one relation. One more relation is only 1, 2. That is also one relation. So like that, this is one relation, this is one relation, this is one relation, one more relation, 1, 1 is there, 2, 2 is there, 3, 3 is there. This is also one relation. Now he is asking total number of relations, how many? He is not asking. He is asking in the total relations, how many neither reflexive nor irreflexive. See the problem. See the problem. In the total relations, how many binary relations on A are possible, which are neither reflexive nor irreflexive? Remember, reflexive means XX pair. Reflexive means XX pair cannot be. Reflexive means all XX pairs should be there. Means 1, 1, 2, 2, 3, 3 should be there. Remember, out of 9 elements, out of 9 pairs, XX pair compulsory. 1, 1 should be there because of reflexive. 2, 2 should be there because of reflexive. 3, 3 should be there because of reflexive. In the 9 pair, 3 pairs are like this. 3 pairs are in the 9 pairs, 3 pairs are like this. So 6 more pairs if you observe. 6 more pairs if you observe. They may be there, they may not be there. Here, one choice only. All 3 should be there. But here, everywhere, 2, 2 choices. So it's going to be everyone 1, 1, 1, 1, 1, 1. So 3 times. Right? But here 6 pairs. Everyone 2, 2 choices. Everyone 2, 2 choices. Everyone 2, 2 choices. So it is almost like 6 times. 6 times. So remember, it will become 1, it will become 2 power 6. So 2 power 6, which is going to be 2 power 6, 64. 64 reflexive relations. 64 reflexive relations. 64 reflexive relations. In the total 9 people, XX pair should be there because of reflexive. Other people, you may take, you may not take, 2 choices. So out of 2 power 9 relations, 64 is reflexive. Next one. Can you see this one? 1, 1, 2, 2, 3, 3. See this one. These people cannot be there. These 3 pairs, if you want to say irreflexive, these people cannot be there. Other people, 6 pairs. Other 6 pairs may be there, may not be there. Other 6 people, if you observe, may be there, may not be there. These 3 should be there one way, that is called reflexive. These 3 cannot be there one way, that is called irreflexive. It is called irreflexive. Then it will become 1 into 2 power 6. It is also 64. So remember, this is irreflexive. It is irreflexive. This is reflexive. So total relations are 2 power 9. In that 64 is reflexive. 64 is irreflexive. 128 remove. 2 power 9 is 512 minus 128. So I think 12, 8 means 4. Right? I think 8, 3, 384. 384 is the answer. 384 is the answer. Verify properly. 384. Please verify properly. reflexive relation 64, irreflexive relation 64. Total relations are 512, 512 minus 128, which is going to be 384. It is not 389. It is a 384. Please let me know if I am wrong. Sardak, please let me know if I am wrong. Please let me know if I am wrong. Reflexive 64, irreflexive 64. Total relations are 512. 512 minus 64, 64, right? Which is going to be 384. Which is going to be 384. Check, it's a nice story. It is a nice story. It is a really nice problem. It is a really nice problem. 6,561 functions. You should know total functions and relations are covered. Total functions and relation is covered. Total functions and relations are covered. How to calculate total number of functions? How to calculate total number of functions? Next one. From there, how to calculate total relations? How to calculate reflexive relations? How to calculate irreflexive relations, and so on. And so on. So please take care of this problem. Please take care. Let's go to next problem. Yeah, can you try? What is the answer of this? Try, everyone. Everyone try. Which one of the following is true? Which one of the following is true? Which one of the following is true? Check, everyone. Yeah, one more thing I want to say to you. It is a MSQ. It is a MSQ. Remember, it is a MSQ. Remember, it is a MSQ. Check one time. Everyone try. Everyone try. Everyone try. Everyone try. So you can draw Venn diagrams. You can draw Venn diagram. You can draw Venn diagram. Or you can take some example and you can check. You can take some example and you can check. Or you can draw Venn diagram. See, A minus B. A here, B here. It is a A, it is a B. So when you say B minus A, B people but not A people. Right? So B minus A. B minus A. B minus A means B people but not A people. So this. B people but not A people. Next one. B minus of this. B people but not this. B people but not this. Check properly. B minus A, B people but not A. Afterwards, B people but not A. Check once, what will happen? B but not B minus A. B but not B minus A. Take some example and you can check. If you want, you can verify also. If you want, you can verify by taking some small examples also. It may be 1, 2 here. It may be 3, 4 here. 3, 4 here. 3, 4 here. It may be 5, 6. It may be 5, 6. Right? B minus A. Right? Let us assume that because of B you want first. B here, A here. B here, A here. You can verify. B minus A. B minus A. 1, 2, 5, 6 minus. 1, 2, 5, 6 minus. Right? B people but not A people. But not A people. Then answer is going to be 1, 2 will come. 1, 2 will come. B minus A. Now B minus that 1, 2. B minus whatever you got, that 1, 2. Right? Which will goes to 5, 6. I think it's going to be middle part. I think it will go to middle part. You can check once again properly here. Once again properly you can check here. A intersection B, common people will come. Common people union B, common people union B. So it will come B. A intersection B. So common people will come. So normal. So A will be the correct answer. It's fine. Now you can take some example. You can check this also. This is also correct. Right? So you can take some example. You can check this one. This is also correct. A people but not B people union intersection. A people. Take some example and try. Or draw the Venn diagram. It's up to you. Draw Venn diagram or take the example. It's up to you. Whatever way you feel you can do. So if you see this diagram, it's the A people, it's the B people. A minus B. A people but not B people. Next one, A intersection B means this one. You are doing union. Total A will come. You can draw Venn diagram also. Answer is going to be A, B, D. It is a very simple problem. Just substitute. Some values you substitute. Right? That's fine. Let's go to next. Can you try this? Someone is saying, please check C. Yeah, C is saying true. It cannot be. Right? You take the example and you verify. So I will verify also. Let me use another color. I will verify also. Let me use another color. A. 1, 2, 3. B. 1, 2, 3, 4, 5. A is 1, 2, 3. B is 1, 2, 3, 4, 5. So B is going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 B. C is going to be 1, 2, 3. So B is not subset of C. But he's saying A is not subset of C. See, there may be chance of A is subset of C also. That is the reason C will be wrong. There may be a chance. He's saying not. There may be a chance. That is the reason. A 1, 2, 3 you take. B 1, 2, 3, 4, 5 you take. Right? C going to be 1, 2, 3 you take. You will get the counter example. So C no guarantee. ABD guarantee. C no guarantee. ABD guarantee. Yeah. Can you try this? Can you try this? Everyone try. Which one of the following function is not 1 to 1? Which one of the following function is not 1 to 1? Can you try this? Which one of the following function is not 1 to 1? Can everyone try? Remember, left side is n cross n. In the function, left side is n cross n. Right side is n. Left side is 2 values. Right side is 1 value. See, left side is 2 values. Right side is 1 value. Left side is 2 values. Right side is 1 value. Left side is 2 value. Right side is 1 value. So that is the reason these options are given. Can you go ahead? So if I give 1 comma 2, f of 1 comma 2, x1 y2, if I give 2x square, 2 into 1 square is 2, 2 minus 8 is I think minus 6. If I give 1 comma 2 minus 6 coming, if I give 1 comma 3, then also minus 6 will come. Then also minus 6 will come. Then how it is 1 to 1? Then how it is 1 to 1? It is not 1 to 1. If I give 1 2, then minus 6 coming. If I give 1 3, then also minus 6 is coming. Because the given expression is not based on y. X changing, right? So x is not changing, y changing. But that answer is not based on the y. So A is not 1 to 1. What about B? What about B? If you see the B, 1 3 also same answer, 3 1 also same answer. If at all 1 3, 1 plus 3 is 4, 4 minus 1 is 3. Right? Both are giving 3. This also giving 3, this also giving 3. It is not 1 to 1. Suppose if I give here 1 3, answer is 1. If I give 1 3, answer is 1. 1 5 also answer is 1. 1 1 also answer is 1. It is also not 1 to 1. Some people are asking, what about option D? Same. 1 3 1, 1 5 1, 1 7 1. So it is also not 1 to 1. It is also not 1 to 1. Can you check? It is also not 1 to 1. Can you check? Two people cannot go to same slot. Two people cannot go to same slot. Two people cannot go to same slot. It is the MSQ. It is a MSQ. It is a MSQ. It is a MSQ. Verify if I am done anything wrong. It is a MSQ. Verify if I am done anything wrong. There may be a chance I may be done wrong. Yeah. Can you go to this problem? Is it same? Is it same? I think same. Yeah, let's go to next. This is also nice problem. Can you check this? This problem also nice problem. Let's see how many people will give. This problem also nice problem. Let's see how many people will give. Try everyone this. Try everyone this. Yeah, can everyone try this? It is also nice problem. It is also nice problem. Can everyone try this? Can everyone try this? It is also a nice problem. So A contain 10 elements. A also contain 10 elements. Total 10 cross 10, 100 pairs are there. Total 10 cross 10, totally A comma B, like that 100 pairs are there. 100 pairs are there. 100 pairs there. So A contain 10 people, right? A cross A contain, right? Like A comma B pair, 100 pairs are there. So some people are asking, sir, can you write a few pairs, sir? So I think it's a 1 1, 1 2, 1 3, and so on, and so on, and so on. 10 1, 10 2, and so on, 10 10. Totally 100 pairs are there. Totally 100 pairs are there. Out of these 100 pairs, which pair sum is? How many pair sum is even? How many pair sum is odd? So let's see the problem. What is asking ensures that. So we need to select. To ensure that we can always find one of the chosen pair that gives the even sum when the numbers within the pair are added together. Okay. So indirectly, directly is asking how many even pairs are there, how many odd pairs are there, how many even pairs are there, how many odd pairs are there. So I will try this. If you want, see this one. Everyone know. Even number plus even number is even. Odd number plus odd number is even. So try to understand. Even number plus even number is even. Odd number plus odd number is even. Both should be even or both should be odd. Both should be even, both should be odd. So odd numbers, if you see 1 3 5 7 9, right? Even numbers, if you see 2 4 6 8 10. So how many even numbers possible is, I think to take the A 5 possibilities, to take the B 5 possibilities, 25 possible, 5 5 is 25. 5 5 is 25. Right? Next one. If you see this one, this is also one more possibility. Right? So A comma B to select. Here also 5 possibilities. Here also 5 possibilities. 5 5 is 25. Remember, this will also give even. This will also give even. Total 50. 50 possibilities. 50 possibilities are there where you will get the sum as even. Where you will get the sum as even. Now see the problem. Now see the problem. Minimum, see this one. Minimum how many distinct ordered pairs from A cross A we need to select to ensure that we can always find one of the chosen pair that gives the even sum. So from these 100 pairs, see this one. From these 100 pairs, how many pairs I have to select to ensure that at least one of the pair is even? Can anyone help me? And one more thing I want to ask you, totally 100 pairs are there. Totally 100 pairs are there. Out of those 100 pairs, 50 pairs are even pairs. 50 pairs are even pairs. And one more 50 pairs are odd pairs. 50 pairs are even pairs are there. 50 pairs are odd pairs are there. So from these 100 pairs, how many pairs I have to select? How many pairs I have to pick? So that at least one of the pair is even pair. So answer is 51 pairs you have to select. To give the guarantee, one of the pair is even pair. To give the guarantee, one of the pair is even pair. 51 pairs you have to select. 51 pairs you have to select. The reason is first 50 pairs may be odd pairs. 51 compulsory even pair. To give the guarantee, at least one pair is even pair. 51 pairs you have to select. 50 pairs are even pairs, 50 pairs are odd pairs. To give the guarantee, one of the pair is even pair. To give the guarantee, 51 pairs you have to select. This is called pigeonhole principle. This is called pigeonhole principle. Whenever we are talking about pigeonhole principle, that time we are already discussed. To give the guarantee, at least one pair is there, even pair. 51 pairs you have to select. Because first 50 may be odd. 51 guarantee even will come. If you lucky, first one itself is even will come. I pick randomly one pair, it may be even pair. I pick randomly one more pair, it may be even pair. If you lucky, one pair is enough to make sure any incident correct. To make sure every time correct. Minimum 51 pairs you have to select. Minimum 51 pairs you have to select. So if you see the problem here, minimum how many distinct ordered pairs from A cross A we need to select to ensure that we can always find one of the chosen pairs that gives the even sum, where the numbers within the pair are added together. Answer is 51. It is an excellent problem. It is an excellent problem. It is an excellent problem. To make all these problems, it is taken to me almost like 1 week. It is taken to me to frame all these problems. To frame all these problems, 1 week I took. 1 week I took to make all these problems. Minimum how many pairs I have to select from A cross A, so that at least one of the pair is there, which is even pair. 51 pairs you have to select. 51 pairs you have to select. Total pairs, how many, sir? 100 pairs are there. In the 100 pair, how many pairs are even sums are? How many pairs are even sums are? 50. How many pairs are odd sums are? How many pairs are odd? 50. Similar way. Some people are asking, how can you say odd also 50? You only say total pairs are 100, 50 even pair. Automatically 50 odd pair. How 50 odd pairs are? How? Even plus odd also odd. Odd plus even also odd. So here series, here both odd I taken, here both even I taken. Now here what I will do is one even, one odd I will take. Here one odd, one even I will take. So totally even, 25, totally 50 odd will come, 50 even. To ensure one pair, at least one pair is even sum, 51 you have to select. You have to select 51. You have to select 51. I hope you got it. If anyone didn't get it, please let me know. 51 pairs you have to select to ensure at least one pair whose sum is even. Hello? To ensure at least one pair is there whose sum is even, You have to select 51 minimum. 51 minimum you have to select. Right. Yeah, with some more problems, we'll see in the next class. With some more problem, we will see in the next class. With some more problems, we'll see in the next class. Fine? Some more problems we'll see in the next class. Yeah. With some more problems we'll see in the next class. Thank you, Jay. Thank you so much. Thanks, everyone. Thank you so much. See you in the next class.